Alright guys, today we are just going to wrap up our unit on solving quadratics by doing a few story problems. Um, so some of these are just edited from previous assignment, but we just need to kind of read and understand the problem. Anytime we're talking about a quadratic, remember that is going to be a U-shaped function. And as in the case with number one, if we have a negative in front of it, that's going to be an upside down U. Anytime there is something being dropped or thrown, we can use a quadratic to model it. If you think of kind of the path that something follows when you throw it, it starts at zero, it goes up and reaches a max point and then comes back down. So that's kind of keep that in mind as you're looking through some of these story problems. Uh, these examples that I'm doing are really actually exactly like the ones on your assignment. We're just going to be using different numbers. So if you follow this video, you should be fine to do the ones on the assignment. Okay, so number one, when an object is dropped, its height can be determined after t seconds by using the falling object model h, so h is the height, equals negative 16 t squared, t is the time that passes, plus s, and s is the initial height. Find the time it takes an object to hit the ground when it is dropped from a height of s feet. Okay, so this is not a multiple choice question. We're not just choosing A or B here. We are doing two separate problems. One when the initial height is 75, one when the initial height is 632. So this is telling me that in my formula here, I have h equals negative 16t squared. This s right here is what is given to me, so it'll be plus 75. So how this works is the height is determined by how many seconds has gone by. It's going to start out, if something is dropped, it's going to start out high and then it's going to drop towards the ground. It's going to get lower and lower and lower, right? Once it hits the ground, it's going to equal zero. So because this is asking us how long it takes to hit the ground, we're going to set our height equal to zero. And then we're going to solve for t. Now, like I said, you can use the quadratic formula to solve any quadratic. So if you wanted to, on every one of these problems, you could use the quadratic formula. I don't always think the quadratic formula is the easiest way to solve, though. So on this one, because we only have t squared and there's no t term in here anywhere, because of that, we can actually just solve this using square root method. So we're just first going to solve for t squared. We're going to subtract 75 from both sides. So that gives me negative 75 equals negative 16t squared. Then we're going to get rid of times negative 16 by dividing both sides by negative 16. So negative 75 divided by negative 16 is equal to 4.6875. That's going to be equal to t squared. Now in order to find what t is, we just take the square root of both sides. So t is equal to, let me just quickly do that in my calculator, 2.165. We're going to keep 3 decimal places here. Now remember this, whenever we take the square root of both sides, when we have a variable, we could have positive or negative 2.165. In the context of this problem where it's talking about time that's passed, we're definitely going to want to take the positive one, not the negative one, because in the context of the problem, the positive one is the one that makes sense. So it hits the ground after 2.165 seconds. Now if we drop it from higher, from 632 feet, I'll put an S here for seconds. We're going to do the exact same process, but instead of putting 75 where S is, we're going to put 632. So solve for t squared. Actually set it equal to 0 first, so because we want to know when it hits the ground. Subtract 632 from each side. Divide both sides by negative 16. Let me grab my calculator. 632 divided by 16 is equal to 39.5. and then just take the square root. Remember, we only want the positive solution on this one. So square root of 39.5 is equal to 6.285. 6.285 seconds. Okay, number 2. So quadratics can be used to model a lot of different things. In number 2, it's saying from 1970 to 1999, the average cost of a new car in dollars can be approximated by the model. So this is a model that approximates the cost of the car based on the year that it was made in. So 30.5 t squared plus 4192, where t is the number of years since 1970. That would make like 1971 is 1, 1972 is 2 years. During which year was the average cost of a new car $12,295? So that would be C, that's the cost. So 12,295 equals 30.5 t squared plus 4192. Okay, again, I can use any method I want. I mean, I could use quadratic formula. I can't use any method I want. I could use quadratic formula here because it works on every equation, but I know that since t squared is the only t term I have, I don't have that other t term, I can solve using square roots again. So again, I just want to get t squared all by itself on one side, so I'm going to subtract this 4192 from both sides. So 30.5 t squared equals, let me just grab my calculator again, so 12,295 minus 4192 equals 8103. So divide that by 30.5, and t squared is equal to 265.67. Let's put one more on there, 2. Take the square root of both sides. Again, when I take the square root, I could have the positive or the negative of the solution. But since it's talking about time that's passing, it doesn't make sense to do, actually it asked me what year, during which year. So it's been 16 years since 1970. So add 16 to 1970. So the year would be 1986. Anyway, it only makes sense to take the positive here, not the negative, because you can't really have negative time. Okay, during which year was the average cost? I'm actually going to skip B because it's the same as A, just a different number. Okay, number 3. A ball is shot into the air from the edge of a building 48 feet above the ground. So here's a building, its height is 48 feet. Somebody is throwing, let's see, or it got shot into the air. The ball got shot into the air from the top and it's heading down to the ground. Its initial velocity is 32 feet per second. And the equation h equals negative 16t squared plus 32t plus 48 can be used to model the height after t seconds. So again, h is the height and t is the time that's going by. So I could think of this axis as the time, and I could think of this axis, oops, probably in here. This axis is the height. We want it to start as it throws up here. Okay, about how long does it take the ball to hit the ground? So again, if the ball hits the ground, the height is going to be equal to 0. So I'm just going to set my equation equal to 0. Now, on this one, I cannot use square roots, right? Because there's a t term here. So what I'm going to do instead is I'm going to try to factor it. I could factor it or use quadratic formula here. Sometimes one or the other is easier. On this one, since I see that all 3 of these numbers are factors of 16, or that 16 is the greatest common factor, I'm thinking it's probably going to be easier just to factor. So if I pull out negative 16 from this, I'm going to get t squared minus 2t minus 3. So I can easily x factor what's left in here. This would be what multiplies to -3 and adds to -2, which would be -3 and 1. So in this case, I feel like factoring is just quicker and easier than plugging into the quadratic formula, but either one will give me the same answers. Since I know this is equal to 0, on this one I would divide by a, but a is 1 in this case. So my two solutions here are either 3 or -1. Again, we don't really need that negative solution because we're talking about time here. So it's going to take 3 seconds for it to hit the ground. So this is the first part of the question. I'll call it part A. So the next part says, how long will it take the ball to be 15 feet above the ground? So if it's thrown up here, at what time is it going to hit 15 feet above the ground? So the difference here on part B is that I'm going to want to set this equal to 15. And I'm actually going to erase this so that I can use the same space to do part B. Wow, it's taking longer than I thought. Okay, so part B, I want to do the exact same process, but instead of setting it equal to 0, I'm going to set it equal to 15 because that's what I'm interested in, is where the height is 15. And then I'm going to find the time that goes along with that. But in order to solve this, I'm still going to have it in standard form with one side equaling 0. So the first thing I'm going to do is subtract the 15 from both sides just to get it in standard form. So 0 equals -16t squared plus 32t plus 33. Now, I don't really see a common factor between 16, 32, and 33. This may be factorable, but it's going to give me some pretty huge numbers. So because of that, I'm actually thinking it's probably just going to be easier to just plug this into the quadratic formula instead of trying to find the numbers that multiply to -16 times 33 and adds 32. You can use either method. It's up to you. Sometimes they will not be factorable, sometimes they will. But to me, it just seems easier to go ahead and use quadratic formula here than try to decide if it's factorable because the numbers are so big. So I'm going to do that. So A is -16, B is 32, and C is 33. So remember, first find the discriminant, which would be B squared minus 4 times A times C. So let's go ahead. I'm just going to put that in my calculator really quickly. 32 times 32 is 1024. Here I've got a negative times a negative, so it's going to end up being plus. And if I multiply those three numbers together, I get 2,112. So my discriminant is equal to 3136. So remember then the quadratic formula says -b, so -32 plus or minus the square root of our discriminant, 3136, over 2 times a, and a is -16. Okay, so I'm going to have -32. In this case, I'm not going to keep things exact. I'm going to go ahead and use the decimal approximation. Oh, but look at that. It's actually the square root of 3136 is a perfect square, is 56, and then over -32. So at this point, I remember I need to divide my equation into two problems, -32 plus 56 over -32, and -32 minus 56 over -32. So if I evaluate this one, let's see. This is going to give me -0.75. And because that one's negative, I'm not going to use that solution because we're talking, again, about time, which should be positive. So the next one, 32, is equal to positive 2.75. So that's the one we want. It's going to take 2.75 seconds for it to be 15 feet above the ground. All right, guys, just go ahead and try the problems today and have a great day, and I will see you on Monday. Next week, we will be taking a test on Unit 10. Monday, we'll review, and Tuesday, we'll take the test.